Now we can go to the examples. Okay, so I'm going to the example. You're given, say, x equals 2t minus t to the 3 and y equals 8 minus 3t. We need to find, so that find dy dx. Okay, that we need to find dy dx and d2y dx, to first derivative and second derivative. So first let us look at dy dt, because it's a function of t. It will give you -3. dx dt will be 2 minus 3 t squared, right? And we have seen dy dx is, you can write either way. You can write dy dt over dx dt, or you can say dy dt times dt dx. So then you just reciprocate it. So this one is coming like -3 over 2 minus 3 t squared. That is your dy dx. Now the next part, you need to take derivative again, d dx of dy dx, which is basically d2y dx2, second derivative. Now first look at dy dx came out with variable t, which is same as -3 2 minus 3t squared to the -1, right? So then, since my function here is a function of t, so I need to replace this one to t. So we'll say that this one like d dt of dy dx, which is basically this function, and then dt dx. All right. Now look at next shape. I need to take the derivative of this function with respect to t. So -1 goes in front, which is 3. 2 minus 3t squared to the -2 times the derivative inside, which is -6t, right? Times dt dx. First look at here, dx dt is this. So dt dx will be reciprocal, which is 1 over 2 minus 3t squared. You are done. Now you just need to simplify and write the nice answer. So I'm writing simplified version of my answer. So 3 times -60 will give me -18t in the numerator. In the denominator, you see that this goes with the square and then another one here. So 3. You get 2 minus 3t squared to the 3. Okay, so this is my second derivative. So we got a parametric function, we got our first derivative and second derivative. I'm going to second example. I take 2 more examples. One is with area and the other one is arc length. Then everything will be covered. Okay, example 2. My next example is so that find the equation of tangent line. Find the equation of the tangent line to the parametric form. Let me say x equals t to the 3 minus 25t, y equals 25t squared minus t to the 4 at t equals 5. So I need to find the equation of tangent line. What we need to know first, what is equation of tangent line? So usually you know that if you have a point like x0, y0 is the point and the slope is known, then the equation of tangent line is y minus y0 m of x minus x0. That one I have mentioned in section 9.1, that one straight line passing through a given point when the slope is known, and this form is called point slope form. Now let us see what is x0. So x naught is actually from here. So t is 5. So you can say 5 to the 3 minus 25 times 5. That gives me 0, right? 5 to the 3 is 125 and 25 times 5 is 125. So this is 0. X naught is 0. Y naught. So I plug it here for y. 25 5 squared minus 5 to the 4. That is also 0, right? 25 times 5 squared is 625 and 5 to the 4 is also 625. So x naught y naught is 0. Now we need to find m, and we know that m is dy dx. So dy dx is dy dt over dx dt. We have seen all of this already. So dy dt will come from here, which is 50t minus 4t to the 3, and dx dt 3t squared minus 25, and in this case you need to say t equals given already 5. So when you plug 5 on this, you get 50 times 5 minus 4 times 5 to the 3, is that right, over 3 times 5 squared minus 25. After simplification you'll find it negative 5. So you got your slope. So the equation of tangent line is immediate now. Y minus 0 equals negative 5 x minus 0. So we got y equals negative 5. So this is the equation of tangent line in Cartesian form. Alright, so we are done.